Good evening. My name is Atul Koshi John, and I'm currently pursuing my BTech Mechanical degree from Karani Institute of Technology and Sciences, Coimbatore, India. So, for the past 1 month, I've been working on a remote internship on design and autonomous flying air taxi and its engine for Uber taxi services and implementation of innovations in the future aviation and aerospace industries. So, I've been doing this internship through College of Aviation Technology, Dhaka, through ISTA. My supervisors are Mr. Suman Sakar and Mr. Muhammad Masum Billa. So, moving on to the contents, I would be talking about the model that I've designed, a brief specifications of the model, the engine and the configuration of the engines, the batteries that I've proposed of using, user focused design, design evaluation, design development, design implementation, and I've also created a mind map that takes the important points and relevant points from the above topics, and I've explained it briefly. Then I will also talk about the experiences that I've had throughout this internship. So, without further ado, so this is the proposed design that I have created for Uber. EVTOL stands for Electric Vertical Takeoff and Landing. So, looking at this model, so I have designed this using OpenVSP software, which is a tool that is developed by NASA for designing vehicles and other aircraft parts. So, looking closely at this design, it is a tri-jet configuration. I'll be talking about that in a brief moment, why I used it. And it's got five engines, and it's got a, a capacity of 5 people. This model is actually pretty aerodynamic, and it actually looks really good and futuristic like. So let me give you brief specifications of the model. So the crew is, so I'm going to talk about general characteristics. So the crew is one, so that's just one pilot. Uh, Uber is actually planning on making this an unmanned vehicle after a few years of successful manned uh, aircraft launches. So they just want to test how efficient their software is, and once they have achieved their goals, they would actually go for unmanned vehicle. Initially, it will be launched with a pilot for the safety of the passengers, and the total capacity of this aircraft would be five, which is one pilot and 4 passengers. Cargo load would be about 600 kgs. That would also include the luggage. Loading and unloading, so that's entry from one side of the aircraft. So if I'm going back to the model, so the loading and unloading would be over here on only one side, just to be uniform instead of creating confusion in the skyports. The wingspan is about 45 to 50 feet, which is similar to the proposed designs by Uber, which is ECRM003. The vehicle height is 20 feet, same as the proposed designs. Flying altitude is 1000 to 2000 feet. Range is about 100 to 150 kilometers for a single charge. That also includes the backups. So I've used 5 Pipistrel E811 electric aircraft engine, and so it would be a 3-bladed to four-bladed because this engine can accommodate a wide variety of propellers. I'll be talking about this engine in a few moments. So this is actually a liquid-cooled engine, and uh, the power is 100% electric because it's an electric vehicle. So there's no emission, there's no sound, and that gives them a hassle-free ride for all the passengers. So they are actually using distributed electric propulsion systems, so DEPs. Moving on, I'll be talking about the engine and the configurations that I've used. So the question would be why I chose Pipistrel E811 electric aircraft engine. So the first reason is that it's certified for use by European Union Aviation Safety Agency, which is EASA. This engine can output power maximum power of 66 brake horsepower. It won't sound much, but it's actually really helpful to keep the plane afloat in the sky. So it's actually liquid cool engine. So it's 50% water and 50% glycol, which is automotive grade G12 plus. So this engine does not consist of any moving parts, so it's really quiet. Unlike the mechanical engines, which has got loads of moving parts. So this is really efficient, and the maintenance is actually really low. So the engine consists of propulsion motors, which is a state-of-the-art axial synchronous permanent magnet electric motors. So that's a feature of it, and I'll be talking about the features of this engine. So it's lighter, it's really compact, uh, it's really powerful. There's no lag in it, and like I've said before, it supports a wide range of propellers. Moving on to the next question would be why a tri-jet configuration? So the reason why I chose tri-jet configuration is because of its the center of gravity is more rearwards, so that actually improves the fuel efficiency. Even while the takeoff and landing, it actually helps really well. It's more efficient and cheaper because it's got less parts. It actually keeps the cabin really quiet because the engine is located at the back and not on the side of the wings. So and actually helps in the easy entry and exit of the passengers from the aircraft as well because there's no obstructions. And in case if there's an engine failure, it reduces the yawing of the aircraft and actually helps stabilizing the aircraft in such a way that they can actually land really safe. Uh, in the aeroplane mode, so let me go to the design. So these two engines are prop rotors, so they can actually adjust itself according to the mode that they're flying in. So in the helicopter mode, they would actually look like this. They would actually be at a 90-degree position, 72 to 90-degree position. And during the airplane mode, they would actually, go horizontal to 0 degrees. And whenever they want to land again, they would slowly adjust its prop rotors at a 90-degree angle and then land safely. So that's what I've discussed over here. So uh, a main part of the electric vehicle is the battery. So battery is like the lifeline of any electric vehicle, let it be a car, a plane, or anything. So for an electric vertical takeoff and landing aircraft to be a really successful competitor in today's world, they need a really healthy and efficient battery. So I've researched about three battery company giants that claims to have done a lot of innovation in the field of batteries. So the first one would be the ChargePoint. So ChargePoint is a company that has a charging station, and they are claiming that they can charge the current present day vehicles and future generation vehicles from 0 to 25% in just 5 minutes and 25 to 90% in 15 minutes. So that's like really fast charging. So they have a liquid cooling technology that supports the thinnest wires, and it's like really flexible high capacity charging cables. So because of this feature, it is actually really scalable. So it's really compact, and if Uber is tying up with such companies, they can actually have their charging station at their skyports, so that when a aircraft lands, they can instantly charge it, and it would just take 5 minutes to charge it from 0 to 25 and 15 minutes to like go to 100. So that actually helps them save time, and it's actually really good. So the next company is Solid Energy. So what Solid Energy is have said that is they've innovated the battery. So instead of innovating the lithium ion battery, they've come up with lithium metal battery. So what they've claiming is that the lithium metal battery is more efficient, uh, and its size is actually they claim to make the smallest batteries, which is half the size and half the weight of a regular lithium ion battery. So they actually have a liquid solvent in an electrolyte, and yeah, so this is actually really a good thing for any electric vehicle, because the smaller the battery and the less weight it has, the better it is, because it actually helps in giving them more range using less power. And having this in an electric flying aircraft would actually help it tremendously, because you can actually put more batteries and it will actually help in keeping up the range, etc. So another battery is the Jeep batteries. So what Jeep batteries have come up with is that they've made an algorithm, which is the active management system algorithm. So using this algorithm, they can actually make batteries more efficient. So they've compared the normal lithium ion batteries that we get day to day life uh, to uh, to a traffic jam, a traffic congestion. So what they've told is that they've compared the lithium ions uh, to a car. So in the road, the cars wanna like go from destination A to B at a really less time. So, but they're restricted to do that because of the traffic jams that we see every day. So they have to move slowly to get from destination A to B. So that's how lithium ion batteries are right now. Even though they want to move fast, uh, they are not able to do because of the the battery technology in today's time. So they are not efficient enough. But using this algorithm, they can actually have ultra fast charging for any lithium ion battery, and it actually improves their battery life. So what I've So researching about all this, I think Uber should tie up with these three companies in order to create a revolutionary battery that would actually help them in increasing their range and using its full potential. So that's about the batteries. So I'll talk about the user-focused design. So why do we require such a solution even if we have uh, a lot of taxi services? So the main thing is traffic congestions in cities, because even if there are many taxi services, people aren't getting from point A to point B in the time that they want. So people actually want to get from from one destination to another at a really short amount of time, but they cannot do that. And people actually tend to waste about 7 days in traffic jams. And there's also rise in pollution and also health ailments because of people, stuck in traffic jams. So they get high BP, back pain, etc. So the aim of this project would be, uh, the aim that Uber wants is to give people a really comfortable uh, travel from a destination to another in less amount of time. And in my design, I've actually focused on the user's comfort. So uh, in my design, I actually located the wing at a high height so that people don't like hit their head when they enter the aircraft. And the wing actually offers shade from sunlight and also rain. And the sliding door actually helps in ease of exit and entry of passengers, the crew, and also the luggage. So being fully electric vehicle, it does not emit any harmful gases. It's actually safer than regular helicopters because helicopters actually depend on a small nut so to fly, and if that fails it's going to come crashing down. And electric uh, eVTOL aircraft does not have that. They're really safe and they have DEP, so they got multiple motors to sustain it to fly. So if one motor fails, there are other motors that will help them to keep it flying. So this is because it's an electric aircraft. It's got no moving parts, so no noise, and so it's a tri-jet configuration. So it actually keeps the cabin really, really quiet. So I focused on the user's comfort mostly. So user must be really happy and relaxed whenever they're flying in this aircraft. So design evaluation. Designing this was a pretty challenging task for me because I thought using Autodesk Fusion 360 or SolidWorks would actually take a little bit more time uh, to create and analyze this design. So I ended up using OpenVSP software, and I've designed it. Designed my design consisted of five electric engines, which is uh, uh, arranged in a tri-jet configuration. So, like I've already discussed before, it helps in the fuel efficiency and also keeps the cabin quiet. So the prop rotors on either side of the wing will actually help it for the vertical lift, and it will automatically adjust its angles according to the uh, flight type that the pilot chooses, which is the helicopter mode or the aeroplane mode. Since it's a VTOL aircraft, it does not require a runway, so only requires a small space to lift off and land. So they can actually be done. They can actually land on top of a building or a shopping complex, etc. So the body of the aircraft is streamlined for a smooth travel, reduces the drag, and yeah, switches between airplane and helicopter mode. So this is a sample analysis that I've done with my laptop. So that's the parasitic drag that I've calculated. So the inputs that gave was given was 200 feet, which is the feet per second, which is the speed at which it would travel, and an altitude of 1,000 feet. And I've got, after calculation, I've gotten these results over here. So this was actually designed and analyzed in OpenVSP software. I've actually run into some difficulties while doing analysis on these uh, aircraft parts. I don't think my computer was calculating properly because it was too heavy for it to handle. But I did most of what I could, and yeah. Like I've already said, the batteries are the driving force for an aircraft or in any vehicle. In this design development, I've taken ideas of what I need to put in my aircraft, and like the model of the wing itself, like how it should be designed, and like what type of engines that I have to use, what batteries that I need to use. So all that was done in design developments. And design implementation. Uber plans to uh, implement this idea by 2023, but I think it's a bit too early to do so because of there's a lot of innovations that needs to be done in terms of batteries, and also in terms of batteries are the main reason for this. Uh, so so they've actually demonstrated their first flight. So they've actually in 2020, and so yeah. So like I've said, they need a lot of work needs to be done with the batteries. So joining forces with the three companies that I've discussed earlier would actually give them a solid uh, advantage over other competitors that are coming, and implementing their ideas. For example, the algorithm would actually increase the efficiency. Solid energy would actually help them in giving the fast charging, and charge point would actually give them like really small batteries. So like joining their forces would actually help them in making a really tremendous advantage, and increase the efficiency, range, and also decrease the weight size of the aircraft. So this is a mind map that I've made. So it talks about the general specifications, engine configuration, batteries, user experience. So yeah, it's a topic that I've discussed. So in the engine specifications, no runway required, the capacity of the aircraft, the load that they can carry, range, the altitude. Engine configuration, so I've used Pipistrel E811 811 electric engine, and 5 of them. And I've discussed why I wanted to use this aircraft. So it's all electric motor, lightweight, compact, instant power, sorry, instant power with no lag, it supports wide range of propellers and it's eco-friendly. Why the tri-jet configuration? Cheaper, quieter cabin, easy to enter and exit, improved fuel efficiency. And I've also discussed about the drawback. The drawback is that it's difficult to control the aircraft, and a really skilled pilot must be necessary to operate this aircraft. And I've talked about the batteries and the user experience, which is they want a quiet and relaxing atmosphere. It should be cheaper than the conventional ride sharing services. So Uber plans to bring Uber Air at a price of $5 initially, and then they'll slowly decrease it $5 per mile initially, and they would slowly decrease it and end up with $0.44, which is 44 cents per mile. It's actually really cheap because it's really time efficient and saves time to reach from destination A to B. So if one is traveling from Los Angeles to New York uh, or Manhattan to New York, for example, by car it actually takes about 2.5 hours, and by using eVTOL aircraft, they can actually complete that ride in 10 to 15 minutes. So it's a really great thing. So I would like to talk about the internship as a whole. So my work, talking about the work, my internship was on design an autonomous flying air taxi and its engine for Uber, and implementing these innovations in the future aviation and aerospace industries. So this was actually a really great opportunity for me because I got to know more about the future advancements in aviation as well as automobile industries. Uh, so the reason why I applied for this internship was because of my interest in designing and also manufacturing, and I learned these topics in lectures and courses in my college and school, and I wanted to implement the topics that I've learned in a real life scenario, and this internship really helped me to do that. Uh, Even though it was a remote internship, it helped me learn new methods and techniques in designing a futuristic vehicle. So I was more into using Autodesk Fusion and SolidWorks, but doing this internship, I got to learn about another software called OpenVSP. So that was pretty, really enlightening and good. Uh, so the experience. So my internship was for a duration of 1 month, and in the first 2 weeks, I was mostly focused on researching about Uber Air and Uber Elevate, which was Uber's initiative to bring the eVTOL aircraft to different cities. So I had to learn about their launch markets, why they chose certain places to launch in first, uh, the companies that they partnered up with for their engine and the designs, the customer needs, cost evaluations, etc. So these topics were discussed in the first 2 weeks of my internship, and the third week onwards, uh, I had to start designing the aircraft using uh, softwares like any software, Autodesk Fusion, SolidWorks, anything. So I had to design and analyze the model. But yeah, so I was balancing my time with my studies, my college work, and also this internship. So it was a pretty uh, challenging task for me. So I thought, why not use a simpler and easier alternative? So that's how I discovered OpenVSP software. But I faced a few difficulties while analyzing the model. Uh, my computer wasn't so strong enough to analyze a few analysis. So I actually ran into a few troubles, but I uh, later partially resolved the issue watching tutorials on YouTube and Google. Uh, so the thing that I've learned during this internship was time management. So time management was the key to manage my college work and also this internship, along with the exams that were piling up. So that was pretty challenging. I would also like to thank Mr. Suman Sarkar and Mohammad Masum Billah for their help. They actually helped me really a lot. So whenever I needed any help or was stuck with a certain topic that I didn't understand, I mailed them and they would like reply to me, reply like really quickly and on time, and they would actually solve my issues. And the online meeting was also really fun. They were really kind to me, and yeah, it was really uh, a really rich and fun experience. So, discover. So, during my internship, I learned the most important thing is that how I learned how to manage my time more efficiently. Uh, Designing the aircraft from scratch was difficult and time consuming, is what I thought using Autodesk Fusion. So, I decided to use OpenVSP software. Uh, I was pretty new to this software, but yeah, I mean, uh, nobody's gonna teach everyone like the whole topic. So one must like take their own initiative to learn a new design software or maybe anything. So there's Google, so there's resources on the web where people can refer and learn on their own. So that's how I learned Novit. Uh, so so it was really interesting time for me, and it actually helped me research more on these topics because I was like really curious after I read Uber's plans. So I read a lot of journal papers, watched a lot of TED Talks and other YouTube videos to help increase my knowledge on the subject. And this actually really helped me. And I hope this would also help me in my future endeavors as well. So that's the end of my presentation. Thank you.